body of mass 6 kg is prevented from moving down a rough plane inclined at 40 degrees the horizontal by an horizontal force of 24 Newton. Find the coefficient of friction. Right, to solve this problem, we need to resolve all the forces acting on the body in the perpendicular direction as well as the parallel direction to the plane. Now this is the diagram we have. We have force due to the weight of the body, which can be resolved perpendicularly to the plane and parallel to the plane. Also, there is an external force 24 Newton, which is horizontal. This time around is exerted on the body to prevent it from sliding down. So we can resolve this 24 Newton parallel to the plane. It tends to act upward and perpendicular to the plane. Right, so those are the forces we need to work on. We know the angle of inclination of the plane is 40 degrees. Okay, now let's go. First and foremost, we need to find a normal component of the force 24 Newton and normal component of the weight of the body to the plane. Now, the normal component of force 24 Newton, this force 24 Newton is a horizontal force. We know that the angle between the plane and the horizontal is 40 degrees. So you can resolve 24 Newton parallel to the plane. That will be 24 cos 40 degrees. But perpendicular to the plane, it will be 24 sine 40 degrees. So the normal component or perpendicular component of force 24 Newton to the plane is 24 sine 40 degrees. So we have gotten one normal component. Now let's get the component of the body itself, the weight of the body, the normal component of the weight of the body, and that is going to be the weight of the body mg, because between mg and the normal direction to the plane is 40 degrees. If you look at this triangle and this triangle as well, you see that they are similar triangles. So this angle is 40 degrees and this angle too is what? 40 degrees. It's a normal thing. So the normal component of this weight mg or 60 Newton is going to be 60 or mg cos 40 degrees. Mg cos 40 degrees. So that is the component of the body itself. Now we need to sum up the normal forces, the normal components, to get our normal reaction. So the total normal component of the forces to the plane is given by the normal component of 24 Newton plus normal component of the weight of the body. That's mg cos 40 degrees, 24 sine 40 degrees. So when we sum up, we have 61.34 Newton. That is the total normal component of the forces. The next thing is to determine to find the total parallel components of the forces. Right? Now, we know that the parallel component of force 24 Newton to the plane is 24 cos 40 degrees. If we resolve this with 24 parallel to the plane, the angle between the force and the plane is 40 degrees. So its component along the plane is going to be 24 cos 40 degrees. And also the component of the weight parallel to the plane, the angle between the weight and the perpendicular direction is 40 degrees. Automatically, the resolution of the weight, the component of the weight parallel to the plane is going to be 60 sine 40 degrees or mg sine 40 degrees. Again, we know that the angle between the weight mg and the perpendicular direction to the plane is 40 degrees. but we are looking for parallel components. Therefore, it's going to be, instead of mg cos 40, we are going to use mg sine 40. So that gives us that the component of the weight along the plane is 60 cos 40, or mg sine 40, or 60 sine 40. So we take 60 sine 40 for the resolution of the weight along the plane. Now we need to find the total parallel components of the forces. So we add the frictional force, which is acting upward, the component of force 24 Newton acting along the plane, then minus the component of the weight acting down the plane. You see that frictional force is opposing the motion, is acting upward, and the component of the force 24 Newton is also opposing the motion, is acting upward, while the weight of the body is the one generating the downward motion along the plane. So that's why we bring this minus. These two are in the same direction, while this is in the opposite direction. So we have to say Fr plus 24 plus 40 minus mg sine 40 degrees. So that is equal to 0. Now if we resolve, we have our Fr to be equal to the sum of, we take this to that side, becomes plus, we take this to the other side and becomes minus. So multiply out mg sine 40, that's 60 sine 40, then minus 24 cos 40, we get 20.18. So that is the frictional force. We know that frictional force is 20.18 now, and normal reaction is 61.3 when we add up the forces. Now our coefficient of friction is usually given as frictional force over normal reaction. That is 20.18 divided by 61.34, and that gives us 0.33. That is coefficient of friction for the forces, right? Okay, I hope you enjoy what we just did, and you understand that you really need to apply the concept of resolution of forces to be able to understand this work clearly. Thank you very much. Once again, I'd like to say that you should go over how we solve the forces. This is frictional force upward, and then the force due to 24 Newton is also tending upward to oppose the motion. Only the weight of the body is acting down the plane. Thank you very much. I hope to see you in my next video.